Hello class, and welcome to section 04, which is on ratios and proportions. By the end of today's lesson, you will be able to compare ratios and solve proportions. So a ratio is comparing two numbers using division. You probably more commonly refer to this as a fraction. So 3/4 is a ratio. You usually are going to call this a fraction. Proportions are an equation saying that two ratios are equivalent. So saying, for example, that 3/4 is equal to 6/8. That's a proportion because we've got two ratios being equivalent. A rate is going to be a ratio with different units. So if I said, let's say, 3 apples over 4 oranges, that would be a rate because it's a ratio with labels, so with those units. And then a unit rate is a ratio where there are two units and the denominator has a value of 1. So for example, if I said there were 8 markers in one box, so the bottom number, that denominator has to be 1. So that's just some vocab revolving around ratios. The first thing we're going to talk about is a cross-product property. This is a way we can use to compare ratios and decide if they are equal. So what this says is that if you have equal ratios, A times D, so multiplying on the diagonal, is going to be the same number as B times C, multiplying on the other diagonal. So over here, we know that 2/5 is the same as 4/10. We've just multiplied by 2. We can check this cross product property and say 2 times 10, which is going to give you 20, is the same as 5 times 4, which is also going to give you 20. So this is a quick way if you can't figure out easily. So this one was easy to see. 2 times 2 gives you 4. 5 times 2 gives you 10. If you can't easily think of that factor to get to the next ratio, you're able to use this cross-product property instead. So we are trying to determine if these two are equivalent ratios. We are going to do that by using the cross-product property. So first, you would say 12 times 23.1, and that is going to give you a value of 277.2. And then we're going to do the other cross product, so the other diagonal, and say 7 times 38.4. And that's going to give you a value of 268.8. So 277.2 and 268.8 are not equivalent. So no, these are not equivalent ratios. Go ahead and try this one on your own. Again, multiplying on those diagonals, when you do that, you get 1,094.4 and 1,155.2. So these are not equivalent ratios. The other thing we can do is solve proportions that have a variable. Again, we're going to use this idea of cross product. So on this first one, I would do 12 times A, which is going to give me 12A, and then 4 times 9, which is going to give me 36. In order to solve this, you are going to need to divide both sides by 12 to get that variable by itself. And when you do that, you're going to get an answer of A is equal to 3. This next one over here, again, using cross-product property, you're going to start with 7 times 25, which is going to give you 175. Then on this other side, we're going to use cross-product property, which means we're doing 35 times the whole quantity, x plus 2. This goes back to what we learned about yesterday, and we're going to need the distributive property to help us simplify this. So the 175 stays the same on that left side. Then we've got 35x plus 70 after we distribute. Now we need to continue solving for x and isolating that variable. So I'm going to go ahead and subtract 70 on both sides. When you do that, you're going to have 105 is equal to 35x. And in order to finish solving for that x, you are going to have to divide both sides by 35, which is going to give you an answer of x is equal to 3. So this cross product property allows us to solve proportions if they have a variable. Go ahead and try this one on your own. So using that cross product, you're going to get 20 times the quantity x minus 2, and then 9 times 40. Use that distributive property, and then add the 40 and divide by 20 to get an answer of 20. Last thing we have here is a couple of word problems. This one says the scale of the map of the Great Smoky Mountains National Park is 3 inches is equal to 10 miles. The length of the Ramsey Cascade Trail is about 1 1/8 inch on the map. What is the actual length of the trail? So our job is to set up a proportion, so 2 equivalent ratios. If we look, we have this first ratio, or rate, since they have units. It's going to be 3 inches over 10 miles. I advise that you put those labels on and make them rates so that you know which value goes with which one. Then the second part is saying 1 1/8 inch. So that's going to go in the numerator because the inch was in the numerator of my first rate. And then I don't know how long the actual trail is, so I'm going to put the x there. Then we can go ahead and use the cross product property to solve. So I've got 3 times x, which is going to give me 3x, and then 10 times 1 1/8, which is going to give me 11.25. Then we can finish off this problem by dividing by 3 on both sides. And when I do that, I'm going to get an answer of x is equal to 3.75 miles. Go ahead and try this word problem on your own. Set it up. Again, I would advise that you include the labels here. So the 232 stores in 2 years, and then you've got 3 years is your other label. Using your cross products to solve, you are going to get 348 stores. If you have questions about this or anything else from the lesson, please let me know when you get to class.